Good day, grade 9s. Today in this video we are looking at area and perimeter, and the first thing up in the video would be the conversion of linear units. In other words, they would be when we're working with straight measurements or with perimeter, which means the distance around a shape. So if you remember correctly from being taught way back when, 1 centimeter is equivalent to 10 millimeters, 1 meter is equivalent to 100 centimeters, and 1 kilometer is equal to 1,000 meters. I'm just going to refer you to the bottom of the page over here quickly so that I can just show you how I teach it. So I teach it like this: 1 centimeter equals 10 millimeters, and then we know that 1 meter is equal to 100 centimeters and 1 kilometer is equal to 1,000 meters, and it's easy to remember like this. And then it's 10, 100, 1,000. But when we convert, like we said over here, from big to small, we times, but sometimes it's difficult to remember which one is big and which one is small. I know it's easy for us grown-ups to remember, but sometimes for you guys it's a bit more tricky. So the trick is, if I write it like this, then that way you times, okay, you can see you times because you go from a small number, 1 becomes 10, it becomes bigger, so we times that way. And then the other way is when we have to divide by the factor of 10, 100 or 1,000. Okay, so this is all you have to remember, the amounts, and then that way we times, and this way we divide. We see that we divide because it becomes from 1,000 to a 1, so to do that we have to divide by 1,000. So you divide by whatever the scale factor is. So from millimeters to centimeters we would divide by 10. Then from centimeters to meters we divide by 100. From meters to kilometers we divide by 1,000. And then the other way, centimeters to millimeters we times by 10. Meters to centimeters we have to times by 100, and kilometers to meters we times by 1,000. Now just the examples over here. Convert 8,56 kilometers to centimeters. And why we need this is sometimes we're given different units on our diagram, and we have to make them the same units so that we can calculate the perimeter or the area. So that's something important to remember that I'll add into the notes over here. Make units the same before doing calculations. Should be something I forgot in this case to put into the notes, but in grade 9 it should come as natural. Okay, so let's get back to the example. So 8,56 kilometers to centimeters. In other words, we want to go from kilometers over here to centimeters all the way over there. That would mean we have to convert our kilometers into meters first by conversion factor 1,000, and we're going that way. See the arrow that way is times. So we times by 1,000, but then we don't stop there because we don't want meters, we want centimeters, so we have to times by 100 again, and that's exactly what they did. Kilometers to meters is times 1,000, and meters to centimeters is times 100, giving you all in all, if you move the comma 3 spaces, it's 8,560, and 2 more zeros added onto that gives you 856,000 centimeters. Okay, then convert 526,000 millimeters to meters. So here's millimeters, and then to get to meters, it's not directly related. We first have to convert the millimeters to centimeters, and then the centimeters into meters. Okay, so we're going that way, meaning, see the arrow this way is divide. So therefore divide by 10, and then once we've got it in centimeters, divide by 100. So 526,000 divided by 10, and that gives you 52,600. And then you divide by 100, the comma moves, space is left, and that means it's 526 meters. Okay, so that is for linear. What do we do with linear units? Something we can do with it is to calculate the perimeter of shapes. So in this, I have summarized for you the, basically this is the definition of the perimeter of a shape. So you just calculate the distance around a shape or the measurement around the outside of something, whatever it is. If we're looking at a real life example, it would be basically your measurement around the outside. And then there are two things you can do. You can just go ahead and add all the sides measurements together. Yes, that's just make sure that they're all in the same units. And then, or two, you learn the special formula and you substitute your side measurements into them. So the first thing we have here is the square. So I'm just recapping over here what we've done in up to grade 8. Something you should know is the square has 4 equal side lengths, so therefore it's just 4 times the same length. It would have been, if I can just write here in a different kind of pen, it would have been length plus length if we just add all the sides together, right? But since we've done algebra, we know of a better way to write this. We can just say it's 4 times that length. So remember, repeated addition becomes multiplication. And then the rectangle over here, that's the length, that's the width or the breadth. I wrote B here because it's standard, but what I refer it to is as a width. I don't like saying the word breadth for some reason. So the way we calculated would have been, if we add all the sides measurements together, length plus breadth plus length plus breadth, then we would have ended up with 2 lengths and 2 breadths or widths. Then the perimeter is 2 times there for each of these, so it's the same thing. We're multiplying both length and the width with, so therefore it's 2 times both the length and the width. That's the formula. For triangles, we have the easiest thing. It's literally, there's no formula really, you just add all the sides, A and B and C. Okay, so if this is the vertex A, then that will be the side length, small a. We label it in such a manner. So this would be the small a. Then this is vertex B, then opposite it will be the side named B, small or lowercase letter b. And then we've got this vertex here, C, so opposite it we will have the side labeled C. So that's literally A and B and C, all the side measurements added together, whatever they may be. Then D, the circle. Remember, just a little recap on something. In a circle, if the measurement is just, or the measurement given is just from the edge of the circle to the middle, then it's called the radius. But if the measurement is given from the one edge straight through to the other side, on the other edge of the circle, well, it's the same edge, then it is called a diameter. It's the whole full measurement. And therefore we know that the diameter is double the size in length of the radius, but the radius is half the size or measurement of the diameter. So this is just a little something I've summarized over here for you. So the formulae would be that the circumference is equal to pi times diameter. Now, where did pi come from? Just a quick recap on that. If I taught you in grade 8, you would know this because I did tell you. So then long ago, they measured with a string around the circle to find its circumference. And then they laid it out straight against a ruler or whatever to measure the circumference. So now, then one day someone realized, and they did a little investigation, and they realized that every time they take whatever the measurement of the circumference, and when they divide it by the diameter measurement, it gives you the same answer, and that is pi. So pi is actually the ratio of the circumference to the diameter. So that is your pi value. That's how it was discovered. Okay, but then they realized they can manipulate this equation. We've worked with equations recently by, and therefore we don't have to measure with a string every time to calculate to measure the circumference. They can just calculate it by multiplying by d. We are eliminating d in the denominator from this side, so times by d on that side as well. So that's my inverse operation to isolate c, and then pi times diameter is equal to the circumference. So they realized, oh, then we don't have to use a string every time and measure the circumference. We can just calculate it. We just have to know what the diameter is, and that's easy enough to to measure. Now from this, just by the way, that's why we have two formulae, you would notice. So pi times diameter, or the circumference is 2 pi r, which just basically comes from the fact that the diameter is 2 times the radius, double the radius. So basically your diameter gets substituted over here with 2 radii, and then that's the circumference. And then it's just rearranged in the structure of algebra, where the coefficient, the numerical coefficient, gets placed in the front. And then any number values after that, which in this case would be the symbol pi. And pi, just a reminder that I'll tell you now, that pi has the value 3,142 that we use when substituting the value of pi. Okay, so enough about perimeter. The conversion of square units, and that would also include when we're working with area, which we'll get to in a second. So for square units, we can kind of relate it to what we learned about when working with linear units. So we knew 1 centimeter is equal to 10 millimeters. Okay, so I'm just going to write it here, 10 millimeters, but that would be that 1 centimeter squared means 1 centimeter, a square of 1 centimeter by 1 centimeter. And that means, in other words, that this 1 centimeter is 10 millimeters, and then that this 1 centimeter is 10 centimeters. Okay, so I'm just going to erase this again. Therefore, 1 centimeter squared is basically 10 millimeters by 10 millimeters. And that means it's actually equal to 100 millimeters squared. So basically all you have to do is to square whatever the linear unit would have been. So we know it's with centimeters to millimeters basically. Now it's squared, therefore the conversion value, the 10, gets squared as well. 10 times 10, and that's how we get to 100. Okay, so in other words, 1 meter squared was 1 meter by 1 meter, and therefore this on the other side would be 100 centimeters by 100 centimeters, and that's how we get to the actual conversion value of 10,000 centimeters squared, covering inside 1 meter squared. You have to think about more or less, and if I would have been in class, I would have given you the actual picture of how big a meter squared is. Now we can't quite imagine how big a kilometer is, but 1 kilometer by 1 kilometer is what 1 square kilometer would be equivalent to. And in meters squared, that would mean, since there's 1 kilometer 1,000 meters, that to calculate the conversion factor for area, we would have to times 1,000 by 1,000, and that gives you, of course, 1 million. Let me just squeeze it in here. Meters squared coverage inside 1 kilometer square. Alright, so just a little bit more detail about that. But then remember, if we convert from centimeters squared to millimeters squared, we would times by the conversion, the 100 or the 10,000 or the million. Okay, and if we go from the smaller units to the bigger units, we would divide by the million, 10,000 or 100. Okay, so if we look at this example over here, convert 0,0512 square meters to square centimeters, you can think about the fact that we're going from, if you don't have this chart with you, from big to small, and therefore we have 2 times, because they can fit a lot of small units inside the big unit. We should think about that as well. So we times basically by 100 squared, because there's 100 centimeters in 1 meter, but since it's square units, we square it. Okay, if you can't, you don't need to remember everything. Just remember with square units we have to square the normal conversion factor. Okay, then using formulae. So firstly, for perimeter, we use the same units as the lengths of the sides. Since we have done the formulae already, let's have a look at the perimeter of this rectangle. So the perimeter would be calculated as twice the length plus twice the width. And then if we substitute for the length, we should firstly note that the units for the length and the width are different. This is in meters, this is in centimeters. Now you can convert any one of these to whatever, because they didn't specify, give your answers in meters or centimeters. So we can, my preference usually, if I don't have to specifically convert it to a certain unit, I would then usually convert the bigger unit to the smaller unit to prevent myself from working with decimals. So I'm going to convert your 12 meters into centimeters. So remember, in 1 meter we have 100 centimeters. So 12 times 100 gives you 1,200 centimeters that the 12 meters are equivalent to. So it's actually 2 times 1,200 plus 2 times 25. Okay, and then therefore it gives you 2,400 plus 50, and that gives you a total of 2,450 centimeters around the shape. For the area of 2D shapes, it's not as simple as just adding the sides together. Since it's not working with linear units, it's working with square units. And it is with regards to that. The definition is the amount of space covered, and keyword covered, by a shape. So the inside, the edges of the shape. So we're calculating how much it covers. This shape, for example, would cover on the inside if we were to color it in. Now, special formula we've learned up to grade 8 is the square. The area's length squared. Length times length, that would be. Remember, that's what L squared means. So length times length. Okay, and then for the rectangle, we work with, once again, remember, let me just insert this here. This is the length, this is the width given, and that would be just plain old length times width. Now, by the way, all the other equations relates to these two equations. They relate to each other. It's just the fact that these sides are all the same, but basically it's the base measurement times itself the whole time to make up this full shape on the inside. That's how many times. That's why we're multiplying it. Now for the triangle, what happens is it's base times perpendicular height divided by 2. Now why this happens is basically what you can do is, let me draw a triangle over here. So let's say I've got, the best way to explain this with the right angle triangle specifically. So basically, in a right angle triangle, we've got our perpendicular height over here, and this is our base. And it's, if we look at it closely, basically half of a square or a rectangle. So rectangle because otherwise our base and perpendicular height would be the same measurement, which could happen. So it's half of the base times the perpendicular height. Now for the other triangles it works the same, it's just that what happens with them is they have to be, let me just draw in the perpendicular height here, perpendicular height. So let's say we cut it off this side, and this is, for example, an equilateral, not equilateral, this is an isosceles triangle. So let's say we cut that off and we go place it there. Okay, then we have a rectangle again. So it's all basically figured out around how we can make it into a rectangle. And then what happens is, now you're asking me, but why isn't it length times breadth? And the fact is that we have now only got over here half of our base. So the breadth that we would then, or width that we would refer to work out this rectangle, is only half of what it was as the base over here. Okay, so that's what happens with other triangles. Then here's my right angle triangle. As I told you, we've got our base, and then our perpendicular height is where your base and your other height meets at 90 degrees. So listen, for an obtuse angle triangle, there is a special way to work it out. Yes? No. It's basically the height measurement is given as to up to the height of the highest point over there. Okay, so here's my obtuse angle. The height goes up to where that highest point is, and therefore it's also half base times perpendicular height. It's just that your base, your base is over here and your perpendicular height goes up to outside the triangle. So there's so that it's perpendicular to your base once again, and that's what's very important. Now you're asking me, how does this become a rectangle? And we can basically make this a rectangle by cutting off, I don't really want to go over this, but you cut off this part over here and you turn it and it fits nicely in here, and then you end up with a rectangle. Okay, so I'm going to wipe it out. I don't want it to stay here in the PDF notes. But yeah, that's basically what happens. Then the circle is, remember your radius, and then sometimes we're given the diameter. Now specifically for the circle's area, we have to always halve the diameter when it's given to calculate the area. We always work with the radius. So the circle's area formula is pi times the radius squared. Okay, so where does this come from, you wonder? I always love to explain where these formulae come from to my kids. Last year, if I told you, you would know. I'm just going to pause, quickly draw a circle for you and explain to you where it comes from. So I've got my circle over here. Now it's not going to be neat right now, but I'm going to draw in some diameters from the one edge to the opposite side, and basically like cutting a pizza, but I'm going to cut it into very thin slices. So let me just start by doing it like this, then it looks neater in the end. But this is how they kind of discovered the formula and got to the area formula. See, I told you it's not going to be neat. Okay, but very, very thin slices, not even that thin. And then what they did was they laid it out end to end, so it forms little triangles basically. So it's so small, these triangles, that outer edge part is not round anymore really. And then what happens is, if you lay it end to end, all of them, okay, it basically becomes, and if you were in class I would have done this activity with you, but it becomes a rectangular shape if you lay them like that. And the last one you'll have to cut in half so that this side is shaped, it's shaped as a straight line, and the other half goes this side, and then it's really a rectangle. And then you're going to see that basically, imagine these edges, where do they belong on the circle? Well, they're the edges, the edge parts all together. So half of it is on this side over here, these edges, half of it is on that side, half of the edges are on that side, exactly half. So basically this is half of the circumference, isn't it? Because the outer edges all together form the circumference. And then, so this relates to the length, because a rectangle would be remember we're trying to relate everything to rectangles, and a rectangle would be calculated as length times width. So the width would be what if you relate it to your actual circle? And it basically, this measurement from there to there, if you look at each triangle here, is a radius. So this is a radius, okay? So radius. Now usually a rectangle would be length times width, and therefore we take the measurement that we've written on the length and the measurement written on the width, and we times that. So the area for this would be half of the circumference times the radius. And circumference can be written as pi times 2 pi times radius, and then times this radius. So I've just substituted circumference over here with the actual formula, and then I can simplify that, and half of 2 becomes 1, which we don't really have to write, do we? 1 times pi times radius, and a different way to write radius times radius is radius squared. And thus that's how the formula exists. Okay, and then for area, square the units when you write the final answer. So luckily for us, in this example with the triangle, we have the same units. We do not have to make them the same. The formula for the area of a triangle, of course, is base times perpendicular height divided by 2. And the base measurement is this one, 12. So 12 times the perpendicular height, the side that meets it at a right angle, is 13, or the measurement that meets it at a right angle. So times 13, and that answer we have to divide by 2. So that gives you 156 divided by 2, which gives you 78 square meters. Meters squared. That is then our answer, or the result. That is how much space it covers, this whole shape. And then the area of other shapes. Now let's have a look. So this is the new work for grade 9. So the area of a parallelogram is related to a rectangle once again. So basically what happens with a parallelogram is it's just slanted that way, and if you cut this little part off here, you can glue it that side, it becomes this rectangle again. But remember, you can't take this height or measurement as your value that you're going to multiply by. It's got to be a perpendicular height always. So therefore it is the base, this is referred to as the base, DA, or even EC if it's given. But what we've got to look for is for a height that's measurement given to us as a perpendicular height. So that's the formula for the area of a parallelogram is base times perpendicular height. So the area of a trapezium, a bit more complicated, but not that difficult really. it's made up of two triangles, okay, and we know how to relate triangles to rectangles already, so it's really not a problem. So the formula for its area will involve adding the two triangles' area together. So just a quick something here, you can see here it's been divided into two triangles. This one is an obtuse angle triangle, and so remember there's your perpendicular height. So it's going to be half of base times perpendicular height. For this one, half of base times the same perpendicular height. Okay, it's just going to be inside the triangle for this one. So therefore the calculation is for ABD half times 5 times 4, and then for BCD is half times 6 times 4, or just 5 times 4 divided by 2, or 6 times 4 divided by 2. So therefore written out like this. And so you'll see that the both of these triangles being multiplied by a half, okay, or being divided by 2, and then both of them is being multiplied by 4, which is the distance between the parallel sides. And so we can rather write it outside and then write what we're multiplying both those things by on the inside. Okay, we call these common factors, basically the distributive method reversed. So it becomes 10 plus 2, 12, and it's 22. So basically the area of the trapezium then becomes the distance between the parallel sides divided by 2. That's the divided by 2 from the triangle formula. But the distance between the parallel sides is your perpendicular height. And then you have two triangles, and each of their bases basically you are multiplying. That's why it's the sum of the parallel sides, which we refer to mostly as A and B. So those are the parallel sides. So it's your distance between your parallel sides divided by 2, and that value you multiply by the sum of the two parallel sides. Okay. Then the area of a rhombus formula depends on what's given. So if the base and height are given, use the same formula as for the parallelogram, because remember, a rhombus is a special parallelogram. But if the two diagonals are given, you use the formula. The area is equal to half times diagonal 1 times diagonal 2. And once again, this relates to there being two triangles, and their perpendicular heights would be your diagonals, basically. Okay, so go investigate that. I'm not going to explain this one as well. And then the area of a kite is also half of diagonal 1 times diagonal 2, because it's also two triangles, basically. Or you separate it into two triangles and you literally work out the two triangles' areas. Great, so let's look at some examples. Calculate the area of the parallelogram below, and we are working. See, now this is where you've got to be careful. They're giving that measurement as well. That's not your perpendicular height. We work with perpendicular heights, therefore that's the perpendicular height we're going to work with. So it's going to be base, which is 5 centimeters, multiplied by perpendicular height 3, and therefore it gives you 15. It was area, so square the unit, centimeters squared. Then the area of the trapezium over here, remember the formula we discussed just now, is the distance between parallel sides divided by 2 multiplied by the sum of the parallel sides. Here's your perpendicular height, the distance between the parallel sides, and then there's your parallel side each. So if we substitute, it's going to be 5 divided by 2 times 6 plus 7. Okay, and you can just put all of that into your calculator because it's a bit more complicated to work out. But it gives you 32 and a half, because you're dividing by 2 and it's an odd number, centimeters squared. Okay, so remember that it's your distance between your parallel sides, the perpendicular height specifically, divided by 2 multiplied by the sum of the two parallel sides. And I would have liked for this to actually be indicated that they did tell you it's trapezium, so automatically those will be parallel. Then in the next example, the perimeter and area of each figure. So for A, the area. Firstly, remember area is calculated by pi r squared, but we've been given the diameter. So you just divide that diameter by 2, and that gives you, so let's replace pi with 3,142 as well. So let's write 3,142. I think as a standard we'd like to do that, times the radius squared. So if we divide 70 by 2, it gives you 35. And that is, just remember to put the square there, sorry about that. That is 3,848,95 centimeters squared. And for the perimeter, it is pi times the diameter, since the diameter is given in this example. So we substitute pi with 3,142, and diameter we substitute with 70, and that gives you 219,94 centimeters linearly. Okay, on to B. The area of a triangle is base times perpendicular height divided by 2, and so that gives you 6 times 7 divided by 2, which is 42 divided by 2, and that is 21 centimeters squared. And the perimeter is, of course, by adding all the side measurements. But let me just tell you something here. Do we have all the sides? No, we don't. We have 6, we have 7, but the hypotenuse is missing. Lucky for us, this is a right angle triangle, and we're able to work out the missing side length. So we have to work out the hypotenuse. So square is equal to 6 squared plus 7 squared, and that is equal to 85. But remember, we don't want the square of the hypotenuse, we want the hypotenuse itself, so we square root each side. That's your inverse operation basically, or because it's difficult to find what square that base would give us. So 85 square rooted is 9,2, that's the wrong color, 9,219. We round to 2 decimal places, so 0.22 centimeters measurement, and therefore the perimeter is equal to 6 plus 7 plus 9,22, and it gives you 22,22 centimeters. We're on C, which requires of us to work with a hexagon, specifically a regular hexagon, seeing that all the side measurements are given as the same length. So what we know is that all the angles are the same size as well. And the other thing that you might not know is that if we connect vertex to vertex over here, we end up with equilateral triangles. Okay, so that means that we have to calculate the area of 6 equilateral triangles. But now the perpendicular height is not given in each of these triangles if it's given like this. So if I take out one of these equilateral triangles, try my best to draw it as such, but then we know, yes, all the sides are the same, 7, etc., etc. But when we want to work out the area of a triangle, we're only interested in knowing this one side length, and then the other thing we want to know is the perpendicular height. Okay, so that's what we don't have. We know this is 7, this is 7. But if you remember correctly, with isosceles triangles and equilateral triangles, if we calculate the, if we have the hypotenuse and we want to calculate the perpendicular height, then we work with only half of that triangle. Then it becomes a right angle triangle, and we'll be able to work with Pythagoras in it. So that's what I'm going to do. I'm going to work with only half of it. Yeah. Okay. So we're working with that to calculate this measurement, the perpendicular height. And that would mean that it is 7, well, perpendicular height squared is equal to 7 squared minus, since we were not calculating the hypotenuse but one of the shorter sides, we minus 3.5 squared, seeing that it's only half of the base that we're working with. And that gives you 49 minus 12.25, and that ends up to be 36.75. And remember, we don't want the perpendicular heights square. At the end of the day, we want the perpendicular height, so we square root each side, and that gives you that the perpendicular height is equal to a rounded value of 6.06 centimeters. Okay, so now that we have the perpendicular height of each triangle, we can calculate the area of 6 triangles. So the area for this would have to be 6 times the half the base times perpendicular height. Okay, so that would be 6 times base in each is 7, and the perpendicular height as calculated is 6.06. But what I'm using is the answer in my calculator, of course, and then that is divided by 2. Okay, so that gives you 127.31, rounded to the nearest second place value, and that would be centimeters squared. Okay, and then for perimeter, it would just be a case of adding all those sides together. So since it's a regular polygon, which is a regular hexagon in this case, it's 6 times the side measurements, 7 centimeters, which is 42 centimeters in measurement altogether around the hexagon. Then for D, we're working with a rhombus, and remember, with the rhombus, it depends what's given to you. You should now ask yourself, has the perpendicular height in this rhombus and the base been given, so we can use the same as with a parallelogram? And it has not been given. What's been given to us has been the 2 diagonal measurements, okay, 3 and 4. So we'll have to work with the area being equal to half diagonal 1 times diagonal 2. And so diagonal 1, just be careful, yeah? This 3 is only for that little measurement, and this 4 is only for that little measurement. So the whole diagonal here is 8, and the whole of the diagonal here is 3. And so we have times 3, 6, and 8. So it's half of 48, so that's 24 centimeters squared. And then the perimeter is basically 5 times 4, because all of the side measurements are equal, if you remember correctly, and it's just going to be 5 and 5 and 5 and 5. So it's 4 times the 5 centimeter measurement. So 4 times 5, and that gives you 20 centimeters perimeter. And as you can see, it's been divided into 2 activities here for you, for area and for perimeter, which you can do over the 2 days that has been prescribed for.